Hello and welcome to another session where we will have a small example of how to use SPSS in linear regression. This is in the topic of statistics, part of our series on introducing basic statistics. And one aspect is to use dedicated statistics software to do these calculations a little bit more efficiently once you understand how the concepts work. So to give it a more practical setting, what we are going to do is use this or reference this book, Statistics and Data Analysis for Nursing Research, where these authors did a study on a certain community with a sample of 1,000 women, I think, and got a whole bunch of data, measured a whole bunch of variables, and made it available on their website. So we are going to go to SPSS and input the A version of that file. They have 3 data files available so that it works on any version of SPSS. It's not too big. We're going to use the A one for that if you're interested to look into that further. So we are focusing on linear regression specifically. So in our example here, we're going to look at the potential relationship between the number of hours worked in a week and the income of a family in this sample. So we're going to start by clicking on Analyze, then go down to Regression, and then over to Linear. I'll make this a little bit bigger, but unfortunately, the list of variables here on the left are the variables are very small here, and I can't really make that bigger in any simple way. So bear with me for now. So we want to see how income depends on the number of hours worked. So our independent or X variable will be the work week variable, number of hours worked in a week, that sits over there. So I'm going to select that and click on this arrow to move it into my independent variables list. Now SPSS can do much more and have multiple independent variables potentially affecting the dependent variable. We'll just keep it simple and do an X variable single affecting a Y variable. So our dependent Y variable, which we usually see as a Y variable, will be the income variable, the monthly, I think it's monthly, the income of the family from these samples. So where is income? I can never find this over here, income. So I'll click that and move it into the dependent list or box. Then I will click on the statistics option at the top right of this window and just double check that estimates is checked. Confidence interval is something you might want to check. Model fit is checked. But you can, of course, do different things here depending on your goals and needs. We'll click on Continue and then click on OK. And in the output window, there's a whole bunch of stuff happening here. We'll just look at a couple of these, mainly the model summary. So let me just click on this and then go to the preview. The print preview allows me to zoom in a little bit more conveniently. Too much zooming, zoom out. And it gives me the R² value over here, as well as if I had more variables, more input variables, more independent variables, X variables that I'm using in my regression all at once, then the adjusted R² could be a little bit more meaningful, but let's just do one thing at a time here. So we could ask a couple of questions. What is the value of R²? It's in the output there, 0.09. Now remember that R squared measures the proportion of variance in the dependent variable explained by the independent variable. So how much of the hours worked is explained by the income of the family, or maybe other way around. How much other way around? My dependent x variable affects my independent x variable affects the dependent y variable. So in our case, we looked at number of hours worked in a week affecting the income of the family. R squared is an indication of how much of the variation in the y variable, in the income, may be attributed to the x variable, number of hours worked. There are other factors as well affecting the income, of course. So it could be a large portion affecting the y variable, or it could be a small portion. So when you go further in the regression topic and consider your calculation with multiple independent x variables, then the R squared value sort of automatically increases when more of these x variables are used, regardless of if they actually contribute in a meaningful way, just sort of a side effect of the calculation. So the adjusted R squared serves as a more realistic or a more accurate measure of how what this contribution actually is. But that's not really something we have to worry about in our initial investigation. So let's close this and let's look at the coefficients here at the bottom. I selected click on print preview simply so that I can zoom in a little bit more and we have something nicer to look at. That's too much zooming. Okay. So we can now see in our regression line that we're trying to calculate with SPSS. We have the constant here, 711 point something, and the slope 23.08. So let's just, for clarity's sake, even though in our previous video in the series, in the playlist, you'll see a video on correlation, and we did look at the same variables and graphed everything. But let's maybe do it again so this video can serve sort of as a more standalone video. We can go to Graphs and Legacy Dialogues, Scatter Dot, Simple Scatter, selected by default, and click on Define. And now we're going to put our variables in again. The work week, hours worked, will be our X variable. And in our analysis, we want to see how it affects the Y variable, which is our income variable over here. Let's put that into the Y. And I think everything is good. Let's visualize it. And there it is. Now, I'm not going to very easily be able to draw the regression line on top of this graph, but we can very easily right click and copy this and put it into something like Word. Let me just make a new Word file here. New blank, maybe something like this. And then I can paste it in there. Zoom out a little bit. And we've calculated the regression line in SPSS. Let me write it over here maybe. Let's see if we, just so we can keep track of it, let's write it over there at the bottom. So that's our regression line, the calculator, the intercept. Think of y equals mx plus b. M is my slope, 23, and my intercept is where it intersects this y-axis. So I could just sort of manually visualize this by inserting a shape, maybe just a basic line. And let's just draw it somewhere over here, like so. Can I edit that a little bit, make it a little bigger? No, I don't draw lines very often. Maybe like that. No, that's black. Blue might be better. Let's just leave it like this. And if I extend it over here, this would be where my 711 what my 711 number corresponds to. And the slope is an indication of the steepness of this line. So it's very hard in general to see, is this really the best line? Which is why we need something like SPSS for large data sets to calculate that actual best fit linear equation, that best fit straight line that tries to describe among all the variations that are possible, that are actually in here, in my randomness in the sample, what is that line that best describes the relationship between these two. And then we can wrap things up by asking a question. For example, let me just maximize this. Asking a question, for example, what is the predicted income for 35 hours worked. We can ask that. And then it's as simple as just plugging this in to my x variable. And we would put 35 in there, do the multiplication, and you can just use any calculator, verify that we're going to get 1,519.56 cents, and that will be my dollar amount that it predicts. If you look over here, for example, at 35, that's 30 over here, 35 sits roughly over there. At our very rough, I'm not saying the blue line is perfectly positioned here, but you get the idea. Follow 35 up, follow it over, and it's roughly around 1,500 as the prediction. But of course, there are other factors affecting family income, affecting that variable. So there is variations. This is just the best prediction that we can make. And we can, of course, make this much more refined by including other variables in our prediction analysis. And that will make things more and more accurate, of course. But this is just a little introduction to get you used to the idea of linear regression and how we use SPSS to do that for large data sets fairly efficiently. All right, that is the end of this video. Feel free to let me know if you have any comments, questions, or suggestions, and we will see each other again in the next one. Until then.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.